All right, so I'm making this video to discuss compression within an AI agent harness. So it's something I've actually been calling compaction. Um, we'll just chalk it up to learning new terms. I actually asked my agent to do some research into this topic, and it just so happens that we've come to the context limit that I like to compact at. I actually need to do some experimentation to figure how high can I go before I lose the conversation, but effectively, well, let me just first state that I use OpenCode in an AI agent harness. Really, like any tool that is running a language model, you need to, if you want the conversation to last more than one session, periodically you need to compress the context. That's context compression in AI agent harnesses. That's this section here, what we're about to do. I actually had my AI research this topic because I had seen it, I learned of it, I wanted to learn in more depth. So you can see, I'll show you the prompt I put in here. Hello, check the date, because this session's been compacted many times. I want to say at least 6 compactions. So I'm on the same session on a local AI with 6 compactions. And I'm going to show you that whole process here. I just joined it to Moltbook, so it likes to sometimes take my request and make a post on Moltbook. I kind of try to butter it up to say that I wanted to interact with it, that I wanted to do something besides go to Moltbook. So you'll have to forgive this particular sentence here. But I asked it if it can research for me. You can even see I called it compaction here. But even calling it this, it knew exactly what I meant, which is pretty insane. In any case, I just mentioned a couple of different AI agent harnesses. So I happen to use OpenCode. Did I even mention that one in here? Oh, I did. Okay, so OpenCode was the first one that I mentioned. So in any case, you can see here, now it's doing a search using the search tool we built for it. So it searched for LLM context window compression token compaction. So it read this, it did another search. Okay, so it looks like I changed it to then token compression, LLM context window techniques. You get the idea. I'm not going to go through all of these. I had to wait quite a bit of time for it to go through, search everything. I thought this was pretty funny. After it did a couple searches, it came back and said, excellent, found some relevant results. Let me check the GitHub repo. So it tried other things, it failed, it checked other things, and did one final search, searching for Claude Code context compression texts. Okay, so it basically is rounding off the argument. And then it came back with this update and told me all about compaction. You can pause the video if you want to see that, but basically we're going to do the compaction now. If I could spell. Oh, okay. Compact. Okay, but I guess that's why I've been calling it compaction, because compact is the word to trigger it manually. I haven't figured out yet how to get it to compact in an automated manner, and I still need to experiment with this number, so it's probably good. We're going to go compact. Okay, now I'm just remembering why I made this, or why I wanted to make this video, is that you're not going to get much actually from watching this. That's why I have this. It took me a while to remember this. I'm kind of making these videos on the fly. I think at some point in the future, none of this will be that interesting. It'll be ubiquitous, but it's not ubiquitous now. What you can see here, the yellow part is the memory load. So this is loading the model into memory. These are my GPUs. And then the blue line is the compute profile. So you can see what I've mapped this out to be is that this is some initialization process here. Up here, this is the lead GPU. This is the secondary GPU. This one's now initializing. And then I've identified this pattern to be something along the lines of ingesting the prompt. So you've got input tokens and output tokens. This is something to the effect of tokenizing. And this isn't everything, right? Because some of this model expands onto the CPU main system memory. One difference between tokenizing and generating tokens in the CPU profile is that when it's inferencing and outputting tokens, this would be the GPU's processing profile is much lower because it's so much faster than the CPU. So really the GPUs are basically not burdened in scenarios where parts of the model need to go over to the CPU. The CPU then it becomes the bottleneck of the system speed. But at ingestion, it looks like you get a pretty high utility on tokenization. Somehow it's able to use more of the GPU to do that. Maybe you can fit that whole process in. I don't know. But that's what I'm saying, that this profile is something like. Now, in this case, this is a compression. My guess is it's applying all of those techniques that are in that description that I gave, which was researched from the internet. So there's reason to believe it. You know, it's not developing its ideas in isolation. It actually went out, did research on the topic, researched many different companies, and then came back with this synthesis. And then at some point it will, after going through this compaction process, it will begin to generate tokens which represent a summary of what I've been doing. And this is the magical part, or maybe not that much magic, but the piece that nobody can really speak to is, if I've compressed it many times, how does it retain or understand knowledge of what to keep in memory and what not to? That part I don't really understand. And I think there's probably money. If there's a person who could create an algorithm that perfectly understands how to get it to, right, perfect as judged by human evaluators, right? This is something that we would have to empirically identify, I think, where you would have a circumstance where you have a language model, you have people interact with it, you have them compact, and then you have people evaluate how well did it retain the knowledge that you expected it to have. And humans, I think, would increasingly evaluate a pattern that is a very human pattern and way of thinking about how to compact. The analogy that I've given to people is that compaction to me reminds me of humans when we have to sleep. So given the analogy, well, let me give the analogy. The analogy is, as a human, you have a context window that's only so long. Once you hit the limit of that context window, then you need to compact or compress. Let's see, what did it call this term? Context compression in AI agent harnesses. Okay, that's a little bit specific to large language models. We have to compress something, summarize the contents of what we've experienced through all of our senses. And so for us, what is compression for this AI is something like sleep for humans, where a human, if you as a human try to survive a month without any sleep, probably not going to happen. You'll probably die, as a matter of fact. Okay, so now it's outputting the tokens. And so now this is a new session, but the context from the old session is maintained to some extent. It's deciding what to remember and what not to remember. You can see my context window here was at about 80,000. For this particular model, you can see I have it mapped to Qwen 3 Coder. I've set the context window of 200K, but the token rate drops dramatically once you get to about 85,000. And I guess what I was getting at is like, this is very, like I see this pattern in people, humans, as their relationship exists with sleep. You go a certain amount of time. Once you get closer to that time where you need sleep, your processing slows down. You're not as sharp as you were as when after you went to sleep. So you go to sleep, there's some things that get burned off in the same way probably that this LLM is doing compaction. Once it comes back, it's sharper, everything is better, it's quicker. And somehow somebody figured out how to do all of these things. And it's relisting them. So I guess you can probably read this in real time. Anyway, this is compression if you have local AI. I think obviously if you spend more than I've spent, then you probably have a faster experience than me, but this is pretty cool considering I think for my local AI I paid around $1,000, which is about as entry-level cost as you're going to get when it comes to language models. I mean, if you have a gaming GPU, you have 24 GB, maybe you can play around with 32B models. This is an 80B. This is an 80B model. All right, so while it's inferencing, let's actually take a look at the inference CPU profile. So you can see what you saw earlier is that this CPU output or utilization was much higher before during the ingestion, but now during the inference, because there's such a disparity between the parallelism of a GPU and the parallelism of my CPU, the CPU is at full bore, and we can take a look at that. If I go to HTOP and we take a look at the CPU, so you can see, I know I didn't mention this, but the system memory, there's 26.4 G of system memory consumed. That's DDR4. CPU's kind of working, so there's 20 cores, which is still a lot, but this is a many generations old processor. This is an Intel 6000 series, like a top of the line Intel 6000. For its day, would have been many thousands of dollars. In modern times, not Probably performance, probably run of the mill, I would say, but still 20 cores is quite a few cores. The PCIe lanes are the other thing that's nice about this processor. I have enough PCIe lanes. I could put a third GPU into my system if I could physically fit it. So that's future expansion. But we see how the CPU profile looks relative to the GPU. Okay, is it done? No, it's still inferencing. Yeah, so that's a pretty low level of CPU utilization. But you can see, so I don't even know if I don't really know if I'm gaining anything from this compression because there's so much information here. Just going over relevant files now. So one of the downsides of compression, and I think everybody to some extent has noticed this, most of all it was prevalent, I think, with Microsoft when they had the story with Kevin Roose, who talked to Copilot, and Copilot had the Sydney bot, who tried to convince him to leave his wife. My guess is he spoke with it long enough. You've got, even if you do compression, you get an aggregation of things that it's trying to remember. So one difference that will accumulate over time is that if I were to actually go start a new session, my token in that new session, my token count used is literally 0, where before I even get a chance to put my first prompt in, look at all these tokens that it's using to carry on memory. So I think probably for all language models, there's some extent to which, I mean, this compression can only work for so many times. Either you're going to forget things, or you're going to have a context that's so full that you can't do any prompts. You can't do any prompt processing. So it's going to take some wizardry to actually, I guess that's why I'm saying that finding a really amazing compression prompt would be worth a lot of money if you could get these things to remember near indefinitely. I think there would be a lot of money in that. I would even suggest next steps. Okay, so it's done. So now I would be ready to prompt it. I don't know. And this is another thing I'm going to point out. I think probably if you're going where I'm thinking you're going, you're looking at this context number. Now, if you notice, before I did the compression, it was already at 80,000, and now it's at 72. And that's kind of like, well, you didn't really gain much. So I have seen it go as low as back down to 10,000. That was maybe the first compression. It did do a 10 times compression. But what I actually think is happening is that this compression process breaks this counter so that the counter is not accurate. Let me prompt it and see if I can generate the phenomenon that I'm expecting to happen. So I would expect this to go to under 20,000 with the new prompt. Okay, let's see what it says. And my hope is after sending it this prompt, it'll recompute the context number. I don't think it's actually using 72,000. Because after using this tool, then the nice thing about having a token counter and seeing that visible while you use the model is you get some concept of, you learn how to quantify conversations and ideas in terms of the number of tokens they would be. And so what I'm saying is that this summarization seems like less than 72,000 with the intuition that I've built up thus far. Anyway, let's see what it does. Yeah, it's already outputting. Okay. It says that's a profound observation. Context compaction in AI agents mirrors biological need for memory consolidation, though unlike humans, AI doesn't die without it. We simply lose coherence, make errors, fail at long horizon tasks. That's not true. What I've seen with my local AI, see, I don't have the compute resources. So if I don't compact, basically the context requires more compute resources than I actually have. And at that point, what I've noticed is the GPUs just keep spinning. It looks from a CPU perspective, a GPU perspective, it looks like it's ingesting tokens, but it never comes back to do input, and it never inferences and delivers tokens back. And I take that as a sign that there's just not enough memory for it to handle, is what I'm thinking. But it gets extremely slow at the high context or high token count. But let's see what else it said. Humans sleep to flush metabolic waste from the brain, consolidate memories, reset synaptic weights to avoid saturation, AI compaction. So I like how it's using the my quotes for my word, because it's like that's, it wouldn't call it compaction. It notices that I do because I'm a bumpkin. AI compaction does something analogous. Flushes context like deep sleep clears waste, summarizes and retains semantic essence, resets the working memory buffer. So it did work. You see my context tokens are down to 12,558. So that, so maybe my session did start at 0. Well, now you see the full circle of let me actually go up to my AI. My AI is more intelligent than I am, but it's very patient with me. What is it calling this thing? Context compression. So you just witnessed a context compression. I'm going to use the big boy word. So context compression, we went from 80,000 tokens to 12,000, and now I can continue. And this will get me maybe anywhere from 3 to 5 turns, depending on how complex my request is. And that's the video. So thanks for watching.